Hello, good day. In this virtual class, we're going to look at how to prove the Heron's formula for finding the area of a triangle if the three sides are given and the height is absolutely missing. Okay, so if you can see from here, we have a triangle A, B, C, triangle A, B, C, and um, here, what we're going to show here, we're going to show that A is equal to the square root of P open bracket P minus A open bracket P minus B open bracket P minus C. Okay, we're going to show that the area of a triangle without the height being given is equivalent to this. Okay, so we have a triangle here ABC, and where AC is B, this the angle B here, the side facing it, the small letter B, while the side facing this angle A is small letter A, which is BC, and this side facing this angle C is AB. So the line AC is equal to B, and the line AC is the same thing as the base. Okay, we should know that AC is the base of the triangle, and AC is the same thing as the line AD plus DC. Okay, here we know that AB is C and BC is A and BD is the height of the triangle. So from triangle ABC, we also obtain triangle ADB, and similarly, we also obtain another triangle CDB. So from this triangle ABC here, we obtain two triangles from here. Okay, so here we will use Pythagoras theorem to obtain AD and DC. Okay, so from figure A, AD square plus BD square is equal to AB square. Here, this is AB, which is the hypotenuse of angle D here. This is a right angle triangle. That means the angle here is 90 degrees. Okay, so here for us to obtain AD, AD is equal to the square root of C square minus A square. From triangle from figure B, which is triangle CDB, to obtain DC here, line DC. Line DC is applying the same Pythagoras theorem, is the square root of A square minus A square. Okay. Then we also know that from triangle ABC, here, the area of the triangle here, the area of the triangle is AC times DB divided by 2, which is the base times the height divided by 2. So, but we know that the line AC is equal to AD plus DC. So we obtain that AD is what? Is C square minus A square, and DC is A square minus A square. Okay, that is B. So we tactically we're going to make use of this expression here. Okay, we're going to make use of this expression here. So here, and we have known that the area of the triangle ABC is the base times its height divided by 2. Okay, so here area is base times height. So we can also make the base times height the subject of the formula, so that the base times height is equal to 2 times the area. Okay, as it is shown here. So we record that B from here, B is equal to the square root of C square minus A square plus the square root of A square minus A square. So here, because we need to move square root of C square minus A square to the left hand side, so we add minus the square root of C square minus A square to both sides. Okay, and this expression becomes B minus the square root of C square minus A square is equal to the square root of A square minus A square. Okay, all we're trying to do here, we'll try as much as possible to eliminate the height so that we can uh, forge ahead. So here we're going to square both sides of this expression here. So if then if we square both sides, the expression become open bracket b minus square root of c square minus a square close bracket all square is equal to this open bracket square root of a square minus a square close bracket square. Okay, so here if we simplify this expression, this becomes b square minus 2b open bracket c square minus a square plus if you square the whole of this expression alone, this is square root of minus square root of c square minus a square all square will give us c square minus a square. Then on the right hand side, with this square applied to here, this square root will be off, and this become a square minus a square. Then the minus h and on the left hand side and the right hand side, they eventually go off, and the expression become b square minus 2b the square root of c square minus a square plus c is equal to a square. Okay, now we need to move all these ones, the one without square root, to one side. So we move all this b square plus c square to the right hand side. This is done by saying add minus b square minus c square to both sides, and the whole expression is eventually reduced to minus b square root of c square minus a square is equal to a square minus b square minus c square. Okay, then again, we still need to square both sides. We need to square both sides. We need to square both sides. Okay, square both sides of this expression. Okay, and here, well, we leave this as it is for now. By though we apply square both sides to both sides, but we square this one alone. This become, if we find the square of this, we square this expression. This will give us minus 2b all square. This will give us 4b square. Then if the square root, if the square is applied to the square root, become open bracket c square minus a square close bracket. So if we expand this, this become 4b square minus c square minus 4b square a square is equal to the right hand side. Like I said, we don't need to touch it for now. It become open bracket a square minus b square minus c square close bracket all square. Okay, now if you can see clearly here, we can see clearly here that 4b square a square can also be expressed as 2b h all square, open bracket 2bh all square. Okay, so and if you recall, you recall that b times the base times the I is equals to 2 as expressed here. Okay, so in place of bh, we will replace it with 2a. That is the implication. Okay, so here record that bh is equals to 2a, and if this is put in 2 open bracket 2bh all square, this becomes 2 times open bracket 2 times a open bracket all square, and eventually it becomes 16a square. So the expression become here. So since the whole of this expression is now 16a square, this becomes 4b square minus c square minus 16a square is equal to open bracket a square minus b square minus c square close bracket all square. Okay, now we will try and move minus 16 a square to one side so that we can simplify. So we add 16a square to both sides. So here the expression, this expression turns to be 16a square is equal to 4b square c square minus open bracket a square minus b square minus c square close bracket all square. Okay, here this expression here for this 4b square c square can also be expressed as open bracket 2bc close bracket all square. So we replace this with this, and this becomes 16a square is equal to open bracket 2bc close bracket all square minus open bracket a square minus b square minus c square, close bracket, all square. Okay. Now the right hand side is a difference of 2 square. If you look at this part here, it's completely a difference of what? 2 square. So if we have the x square minus y square, the expression is sitting as open bracket x minus y, close bracket, open bracket x plus y, close bracket. So here where s is 2bc and y is a square minus b square minus c square. So if we substitute this on the right hand side here, on this part, so we see that the expression here become the right hand side become open bracket 2bc minus a square plus b square plus c square, close bracket, open bracket, 2bc plus a square minus b square minus c square, close bracket. Okay, then you see that the whole expression here, this expression here, can also be grouped as b square plus 2bc plus c square minus a square. Okay, similarly, this expression here, this part here, can also be expressed as a square plus 2bc minus b square minus c square, minus close bracket here. So, but this expression here, which is this part alone, okay, which is this part, can also be expressed as this. So this expression here, 2b square plus 2bc plus c square, is the same thing as open bracket b plus c all square. Okay. Similarly, the expression here, the expression 2bc minus b square minus c square can also be expressed, which is this, can also be expressed as minus open bracket b minus c, close bracket, all square. Okay. So that by the time we put this in this expression again, put it in this expression, it becomes 16a square is equals to the large bracket b plus c all square minus a square, close bracket, then open large bracket, a square minus b minus c close bracket all square, with a close bracket, a large close bracket. Then you could also see that this expression here now, they are also difference of 2 square. So where x is from this expression here, s is b plus c and y is equals to a. Then for this expression here, s is equals to a and y is b minus 6. And if this is applied here, this become b plus c minus a, close bracket, open bracket, b plus c plus a, close bracket, then open bracket, a minus b plus c, close bracket, a plus b minus c. Okay, here we have to do some manipulation. Okay, we need just to do some manipulation here. Now, here we have look at it, this is a plus b plus c. We can also written as a plus b plus c here, as you can see here. Then similarly, b plus c minus a can be written as, we can manipulate it. We can say, let's look at this carefully. If I say a minus 2a is the same thing as minus a, written as minus a, that is the manipulation we did there. That is the manipulation that we happened here. So from here, this expression here, b plus c minus a, can also be written as a plus b plus c minus 2a. Okay, this expression here, the expression here is the same thing as this expression. Okay, because a minus 2a is equals to minus a. So similarly, here we have a minus b plus c. It can also be written as a plus b plus c minus 2b. Similarly, for a plus b minus c can also be written as a plus b plus c minus 2c. Okay, now some transformation has to be done here. Here we let the whole of a plus b plus c, let e be 2p. Okay, you know that the P there is simply what we call the semi-perimeter. Okay, so we can also say that P now is A plus B plus C divided by 2. So we replace whenever we see A plus B plus C, we replace it with 2B. So the expression now become uh, 16A square is equals to, in place of A plus B plus C here, we put 2B. Here in the first part of this bracket here, A plus B plus C is equals to 2B, and here we have minus 2A. So similarly here, we put 2B minus 2B, and here 2B minus 2C. Now, you can see that we can factor out 2 from each of these terms here. Each of these terms, 2 can be factored out, and 2 times 2 times 2 times 2, that means 2 in 4 places. 2 in 4 places, that is 16. So the expression become 16A squared is equal to 16P into P minus A bracket P minus B bracket P minus C. Okay. Uh, Once that is done, okay, here we divide both sides by 16, and the expression becomes A squared is equal to P into P minus A bracket P minus B into bracket P minus C. Uh, Hence, we take the square root of both sides because we are looking for A, which is the area, and this becomes A square. A is equal to the square root of P into P minus A, close bracket, open bracket, P minus B, close bracket, open bracket, P minus C. Okay, this is how to prove the area of a triangle. That is the one we call the Heron's formula when the three sides are given. Please, if you like this video, help me subscribe to my YouTube channel and also share it to other social media platforms. Till I see you in my next virtual class. Have a nice time.